So now that you saw the demo of SQL injection, let's see how we're going to protect against SQL injection. There are generally 3 methods for protecting against SQL injection, but since the users are not targeted at, you don't really have to worry about it. The web programmers and web administrators protect against SQL injections using methods known as prepared statements, sanitizations, and web application firewalls. Now let's get to XSS, which stands for cross-site scripting. But since CSS is taken for something else, the name goes as XSS. XSS leverages the web server to attack web users. So it's a little different from SQL injection, and it's a little more prevalent to the average user. So you have to pay attention what it is, because you are the target. So you should know how to defend against it. It has 3 forms, each one more complicated than the last. Reflective XSS, persistent XSS, and DOM XSS. So the way XSS works is that it first attacks, the first attacker sends data to the server, then server sends that data back to another user, which is the victim. But this data does malicious stuff on your browser. So the browser is the software that you use to browse websites such as Internet Explorer, Mozilla Firefox, and Google Chrome. These browsers support a lot of different things. So if a server sends something malicious to them, then they run something malicious. And an attacker can abuse a server that's vulnerable to send the payload that the attacker created back to other users. Think of it, for example, as a Facebook post that instead of having some text, steals your passwords from the computer. Fortunately, Facebook is not vulnerable to that, so it's not easy to do that on Facebook, but a lot of worse websites are vulnerable. This data is usually in JavaScript formats, JavaScript code. It runs on your browser. It does the things that the attacker wants. It can steal your cookies, which are pretty much the same as your username and password. It can mine Bitcoin. It can install malware, and it can abuse your computer in a large capacity. How do we defend against XSS? Because XSS is very common and all websites, including Facebook and Gmail, have vulnerabilities in it, and your account can be stolen by it, you really need to know how to defend against XSS. The first thing to do when defending against XSS is to never click on links sent by strangers. I know your parents already told you that, but I have to emphasize that again. Do not click on links that look suspicious and sent by people you don't trust, especially links that are longer and have weird characters. It doesn't matter if it's on Twitter, if it's on Facebook, or on any website. As long as you do not click on things that you do not know, the risks of getting XSS vulnerabilities and XSS exploits on your machine are minimized. Also, do not visit unknown websites, but that goes without saying. And if you want to be 100% secure against XSS, you have to disable JavaScript. So all modern browsers let you do that. But if you do that, you can't use a lot of features on a lot of websites because they use JavaScript. Now, the last attack we want to talk about is known as CSRF, cross-site request forgery. Attackers can use this attack to do stuff on your behalf without you even realizing it. Examples of CSRF are, but are not limited to, voting on your behalf, transferring money on your behalf, sending messages and email on your behalf, and doing other stuff on your behalf. So you don't want to be vulnerable to CSRF. This vulnerability needs to be protected on the server. There's not really much you can do about it. But to minimize the risks of you getting exploited via CSRF, just like XSS, first, don't ever click on suspicious long links. And second, do not visit untrusted pages. And the third, use a separate browser to visit untrusted sites. So for example, if you want to click a link and you don't know where it goes and you don't know what site that is, just open a new browser. If you're using Google Chrome by default, you can use Firefox as a separate browser. If you're using Firefox as default, you can use Internet Explorer as the second one. As long as you are not logged in other websites in that browser, CSRF cannot abuse you. So for CSRF to abuse you, you have to use the same browser in which you are logged in inside another application, whether that is your banking application, whether that's a voting application, or anything else. There are also binary attacks. These attacks target executable programs, such as the exe files you know on Windows. Each operating system, such as Windows, Linux, and Mac, has its own executable file format. For example, on Windows it's PE, portable executable. On Linux it's ELF, extensible Linux format, and on Mac it's MacO. Each one of them works slightly differently, but they ultimately all run on hardware, which is x86 in the case of the examples above. Binary attacks are generally much harder than web attacks. The example of exploiting the buffer overflow that we saw in the C program before was an example of a binary attack. The first type of binary attack is a buffer overflow, the exact same thing that we saw. Operating systems generally protect against it using stack canaries. They use data execution prevention, DEP, or address space layout randomization, ASLR. But it's still possible to hack systems through buffer overflow, although it's very, very difficult for the attackers. The more complicated type of overflow is a heap overflow. It's slightly more complicated than buffer overflow. It's more often hacked because it's more complicated and thus less protected against. It relies on dynamic memories rather than static memories that are used in buffer overflows. It's really hard to exploit and requires a lot of smashing and a lot of code by the attacker. The other type is integer overflow. It's completely unrelated to the other two overflows, although it has the name overflow in it. For example, in a computer, because of the way numbers are implemented in hardware, if you add the number 1 to the number 32,767, the result would not be 32,768. But it would be negative 32,768. Why? Because that's how the computers work. Computers do not allow infinite numbers on them. They have an upper capacity at which when you add 1 to the number, it rotates around and starts from the bottom. So if you add 1 to the top, it goes back to the bottom. And if you remove 1 from the bottom, it goes back to the top. That's why it's called an overflow. This system is known as 2's complement. You can Google it and read about it. And that's how computers were made for a multitude of different reasons. So if a programmer is not paying attention, an attacker can enter a number that overflows. For example, an application says, "How old are you?" And you enter negative 32,767. And it says, "Seems like you were born on 2018 minus 32,767, which is the same as 30,750. And this application thinks that you were born on a year after today, even though it expected you to be born on some day before today. There are also Jade Attacks, which are attacks on just-in-time compilations. These are very complicated attacks. A lot of modern software uses a compiler that's a just-in-time compiler. It comes along with the code, it compiles the code as it runs. And these are really hard to reason about, really hard to protect, and really hard to exploit. But these are becoming more and more common because they use dynamic languages such as JavaScript, which powers half of the internet. These are very complicated pieces of software, and thus they're vulnerable to many bugs, and that's all you need to know about JITs. There's also Crypt Analysis, which is breaking cryptography systems. It's usually done by people who have 20 or more years of mathematics and crypto education. It's a real hard thing done by NSA and some other corporations. The usual run-of-the-mill hacker doesn't do this very much. Even though I have done about 10 years of cryptography, I'm still not very comfortable doing cryptanalysis on myself. It's really hard, it's really low level, and it involves a lot of math. It's usually done by military hackers and professors, and it doesn't really concern us because of that. So it's very unlikely that you see someone attacking you using cryptanalysis.